The term AI is used to describe a navigation app, a chatbot, and a self-aware machine from science fiction. Treating them as the same thing is a mistake, and that mistake changes how we understand what the technology can and cannot do.
On one hand, the label applies to simple, practical tools that are now part of our daily lives. It's the system on your phone finding the fastest route by processing traffic data, a highly specialized single task. It's also the automated agent handling customer service questions by recognizing patterns in language. And yet, that same term is used for the theoretical, conscious machines of fiction that would possess their own beliefs and desires.
This single label is misleading because it covers a vast and incompatible range of capabilities, from simple pattern matching to hypothetical consciousness.
Confusing them creates flawed expectations. This leads to both exaggerated fears and misplaced trust in what today's systems can actually achieve.
To clarify this, we need to break down AI by its actual capabilities, its functionality, its real-world applications and risks, and its fundamental limits.
The most important distinction to make is based on the breadth of an AI's intelligence. This separates what exists today from what is purely theoretical.
The first category is artificial narrow intelligence, or ANI. This type of AI is designed and trained to excel at just one specific job. And this is the crucial point. Every single AI application in use today is a form of narrow AI. It is the only type of artificial intelligence that has been successfully built. This shows the spectrum. On one side, you have the specialized, single-task focus of today's narrow AI. On the other is the theoretical concept of artificial general intelligence, or AGI, which would be as versatile as a human mind. Since all current AI is narrow AI, we can sort it further by how it actually functions. All existing narrow AI systems fall into two functional types. These represent a progression in complexity, from systems that only react to the present to those that can learn from the recent past. Reactive machines are the simplest form. They see the world and act on that information, but they cannot form memories or use past experiences to inform their decisions.
The classic example is IBM's Deep Blue, the computer that defeated Garry Kasparov in chess. Deep Blue analyzed the board and predicted the best move for that exact moment. It treated every turn as a new problem, with no memory of past games.
The next step is limited memory AI. This is where AI starts learning from the past. These systems can look back at recent data to make better decisions right now.
This technology powers almost all the AI we use daily. A self-driving car observes other cars' recent speeds, virtual assistants learn from your commands, and generative AI uses the words you just typed to predict the next ones.
Despite how powerful these systems are, it is critical to understand how they perform in the unpredictable real world. Their limitations are key. While a narrow AI can perform its task at a superhuman level, its intelligence is often called brittle. It is highly optimized for its training data, but lacks any real-world understanding or flexibility. This brittleness means that when faced with a new situation it wasn't trained for, a narrow AI can fail in strange and unpredictable ways. It has no common sense to fall back on. These failures can have serious consequences. An autonomous car could misinterpret an unfamiliar road sign, or a hiring algorithm trained on biased data could perpetuate unfairness. These aren't malicious acts, but the inherent limitations of a system that only matches patterns and doesn't understand context.
This brings us to the final and most important distinction, the clear line between what today's technology can do and what remains purely theoretical. Today's AI is a sophisticated pattern matching tool. It learns statistical relationships in data to do things like classify images or translate text. But it has no self-awareness, no consciousness, and no genuine understanding of human emotion. Those abilities belong to general AI, which does not exist.
This distinction is critical. An AI that plans a driving route is fundamentally different from a hypothetical machine with beliefs and desires. And this raises a serious question. Is one label, AI, still useful for describing such different realities?